The first section in your textbook, section 1.1, deals with the concept of interval notation. Now, interval notation is something that we're going to use quite frequently in calculus, and its purpose is to represent a set of numbers, but to do so in a much more efficient way than the traditional method of set notation, which you probably have studied before. So what I've done here is I've drawn a variety of situations, and I'm going to take you through and show you what these sets would look like using set notation, and then using this new system called interval notation that we're going to use throughout this course. So if you look at the first picture, this picture right here, we'll call it number 1. What I've done is drawn a real number line. And on that real number line, I've indicated the endpoints of a region, the endpoints being -2 and +4. And you notice that the -2 and +4 have solid dots on them. That's to indicate that the actual numbers -2 and 4 are meant to belong to that set. And then I've shaded in the region between the two numbers. So what I'm indicating here is a set of numbers that would include -2 and all the real numbers from -2 to 4. So the whole numbers, fractions, decimals, irrational numbers, 0, every possible number between -2 and 4 that's real. Now, using set notation, which is a notation that you're probably familiar with, what we would do is we would open up a brace to indicate that we want a set of numbers, and then we would say that the set is, and we'd pick a variable, traditionally x, so we would say all values of x such that, and then we would go on to describe the numbers that we want x to be. And using set notation, we would use inequality signs. So we would say that x has to be greater than or equal to -2, or less than or equal to 4, and then we would indicate that x can be an element of any real number. So that is called set notation. Now, there's nothing wrong with set notation, it's just that it's quite lengthy, and the number of times in a calculus class we refer to intervals, it becomes a bit awkward to have to write that out every time. So what we're going to do is introduce a new method of doing this called interval notation. And it's very simple, and you'll see in a moment how efficient it is. What you do is you simply take the two numbers that are bounding your region, in this case the numbers -2 and 4, so you would just indicate -2 and then put a comma and 4. Now all we have to do is somehow determine, do we want to include the number -2 in the number 4? So if you do want to include the number, then you put a square bracket surrounding the two endpoints. So that square bracket right there, that means equal to. Now you can see how much more quick and efficient this is. So by looking at this interval notation, I know that I want all the real numbers between -2 and 4, including the endpoints -2 and 4. Now on our next example, number 2, you'll notice I've indicated the same set of numbers, but this time the number -2 has an open circle on it. That open circle means that we want to go right up to the number -2, but not actually include it. So we'd go to -1.999999. It's obviously difficult to express that, but we want every real number up to -2, but not including it. So using our set notation, we would say all values of x such that x is less than or equal to 4, greater than -2, and we wouldn't put the equal sign, and then we would say x is an element of the real numbers. Using our interval notation, we know we're going to have the endpoints -2 and 4, and we know we want to include the 4, so that was a square bracket. So all we have to do is come up with a way of indicating that we want to go right up to a number but not include it. And the way we do that is with a round bracket. So we put a round bracket. The round bracket indicates that it's not equal to. And that's it. That's interval notation. It's just a faster and more efficient way of indicating a set of numbers without using the inequality signs and just using the system of brackets. I've got a few more examples here just to show you some other things that could occur using our interval notation. So if you look at the next example, we'll call it number 3. In number 3, I've indicated that we want the set of all numbers starting at and equal to -2 and extending all the way to positive infinity. There's no endpoint on the right-hand side. So -2, -1, 0, 1, 2, 3, 4, 5, all the way up to infinity, and all the numbers in between, all real numbers. So again, using set notation, we would say all values of x such that, and then we would just say x is greater than or equal to -2, x is an element of the real numbers. Using our interval notation, our first endpoint is -2. Now we don't have another endpoint, so the question is, what are we going to put there? Well, this set is going to continue on to the concept of infinity. Now, infinity isn't an actual number, it's just really a concept, but we can indicate that with the symbol. The symbol for infinity is just a sideways 8. The question is, square brackets or round brackets? Well, the -2 is to be included, so that's a square bracket. You can never actually reach infinity. Infinity is just a concept. It's not an actual place that you can reach. And so you always use a round bracket when you're referring to infinity. So this interval notation would say that I want all real numbers beginning and equal to -2, extending all the way to infinity but not getting to infinity. In our next example, number 4, we have all the numbers between -2 and 4, and this time we don't want to include either number. Now, I think I've already reviewed with you enough the concept of set notation. We're not going to use set notation in this course, so I'm not going to bother writing it down every time. We're just going to write this using our interval notation. So our endpoints are -2 and 4. In this case, we don't want to include either number, so we're going to use round brackets. And the reason why I've illustrated this example is this is the one problem with interval notation. You'll notice that that looks familiar. If you put two numbers like -2 and 4 in a set of round brackets, it looks like you're referring to an ordered pair. And so the question is, do you have an ordered pair or do you have a set of numbers? And so this particular situation right here, this can be confusing. That is the only downfall really to interval notation. Now there is one way of avoiding that. Some people like to write their interval notation, especially if it's an open interval like this, is they'll write it with the x is an element symbol in front. Like that. Now we're clearly indicating that we have a set of numbers. I personally don't use the x as an element of because it's just an extra step. I'm trying to write this in an efficient way. And so you just have to understand that depending on the context of the question you're doing, sometimes the round brackets can indicate a point, an actual dot on a graph, and sometimes they can represent a set of numbers or an interval. If the interval does have round brackets, which means you're not including the endpoints, it's called an open interval. So we would call this, right here, this would be referred to as an open interval. And the first one that we did, with the closed brackets, this would be called a closed interval. Just some terminology you're going to see throughout this course. And finally, I have two more examples I'd like to share with you. And the reason for these two examples is now we have a situation where we have sets of numbers that are being combined. And so if you look at the first one, we'll call this one number 5. We want all the numbers starting at -2 but not including -2 and heading off to negative infinity, or all the numbers starting at 4 including 4 all the way to positive infinity. And we want to write this using interval notation. Now to do this, I have to introduce a new symbol to you, so I'll show you how you would write this. For this part right here, if you just look at this section of the graph, we want to go from negative infinity to -2, and we don't want to include either one. bracket at infinity, and in this case a round bracket at -2 because we're not including it. If we look at this set would be a square bracket starting at 4 and going all the way to infinity. And the new symbol I have to show you is the union symbol. You probably have seen it before. It's just a U. This is called the union symbol. And union just refers to if something is a union, it's a joining. So union just refers to the joining of two sets. So the way you would read that is you would just say all numbers from -infinity to -2, union 4 to infinity. And finally, our last example, we'll call this one number 6. I've just thrown in another situation here with just some round brackets and with some open circles and closed circles, just so you can get a handle on this. And I think you can appreciate how easy this interval notation is compared to set notation. All we have to do is indicate with either round brackets or square brackets whether we want to include our endpoints. So we want all the numbers from -3 to 2. So -3 to 2. The -3 is not included, so a round bracket. The 2 is included, so square bracket. Union, we want to go from 4 all the way to infinity. The 4 is not to be included, and of course we don't include infinity. And that, folks, is what we call interval notation. And when you get into the actual calculus part of the class, you're going to see that we're going to use this quite frequently, which is why it was a good time to share with you this new way of doing that.